So good evening, everyone. We'll just start in another 5 minutes. We're just waiting for more participants to join in.
Sounds great.
Okay. All right. So good evening, everyone. A very warm welcome to our last meetup for the series of AI and Azure. So I'm Shubham, currently working as a program manager at Skillenza, and today we have Ari with us, who would be talking on building custom ML model using Azure Machine Learning Studio. So we planned a series of 4 online meetups, which would help you to skill your knowledge on AI and Azure. So now Like before we get started with the speaker session, I'd just like to tell you about Scalenza and the flow of today's event. So we are a challenge learning platform. So we use challenge models to help companies to discover relevant talent and hire better people. So the flow for today's online webinar would be pretty much simple. Ari would be taking up the session. Post this, we'll have a Q&A, and then we'll have one of our top teams of Mishmash who will be demonstrating their project in one of our hackathons, which how they have built. So now over to you, Ari.
Perfect. All right. Let me share my screen and let's get started.
Yeah, you can just. I think my slides were not working. No issues. You can just
No,
share. Yeah,
no worries. Can you guys see my screen?
yeah. All
Awesome.
good.
All right. So today we're going to be talking about building custom models for all skill levels using the Azure Machine Learning Platform. Before I get started, just a little bit about myself for those who might not be familiar. My name is Ari Bornstein. I'm a senior AI and machine learning developer advocate for Microsoft. I'm based in Tel Aviv in Israel. And for those of you who might not be familiar with what it means specifically is I work with different open source communities, trying to help every developer to be successful with AI on the cloud. And specifically, I work a lot within the Israeli tech ecosystem and startup ecosystem. And we collaborate and do all sorts of partnerships to try to develop content which we can scale out and help other developers to be successful on the cloud. So before I get started, let's go through a little bit of the agenda of what I hope to cover today. We're going to start with a very high-level overview of some of the machine learning applications and spaces that we're seeing a lot of digital transformation and disruption from machine learning. We're going to talk about Azure Machine Learning as a platform. We're going to see some demos around workspace and pipelines. And then we're going to go in and talk about how at each level of your data science expertise, from novice all the way to expert, you can leverage the Azure Machine Learning model to put custom models into production. So from using the AML designer to getting your first models running with AutoML to taking it to the next level with the Azure Machine Learning SDK. And we'll see a real-world computer vision scenario that transcends, the very standard MNIST examples that we see. And then at the end here, we'll be looking at, I'll open things to questions and answers. If you guys have questions, they'll be moderated, and I'll do my best to answer as many questions as I can. So with that, let's get started. So we've seen in the past 7 or 8 years, a huge digital transformation and disruption based by a lot of the changes that are going on in the machine learning space. Started first and foremost in the world of computer vision, but also that transcended a lot of areas from forecasting, natural language processing, genomics, image comprehension, reinforcement learning, self-driving cars, predictive maintenance. And we see pretty much that we have a direct impact here in almost every Fortune 500. In addition to that, a lot of the startup and global ecosystems. So, and when we look forward, we see that AI is going to continue impacting the work that we do, and it's going to be more and more important. So it's important to dive in and really understand what this means and how we can take advantage of it. So from there, let's talk a little bit about what Azure Machine Learning is. Azure Machine Learning is a platform that enables data scientists and AI and machine learning engineers of all levels to be able to better and more effectively develop machine learning applications. One of the additional key features of the Azure Machine Learning platform is the ability also to build production pipelines, which then can be iterated as well. So I'm going to quickly kind of show you what the Azure Machine Learning workspace looks like. I'll walk you through a couple of the high-level features, and then we'll walk into how data scientists or machine learning engineers at any level can get started with the platform. So essentially what I'll do is I'll go into my browser here, and I go to ml.azure.com, and this will bring me to my Azure Machine Learning workspace. To create a workspace, so you just go to the portal, create new workspace, and you can set it up. If you're interested in how to do that, just search create new Azure Machine Learning workspace. And I also have a demo as well, which I'll show you some content as well that shows you how you can get started with a free Azure subscription if you want to learn how to do more of these things yourself at home. But you just go in here, create a resource, search in the marketplace, machine learning workspace, and from there, it will take you to this view. In this view, we see that we have a couple features. I can see a lot of the different experiments. We're going to dive deep in a little bit what those look like. I can see notebooks, automated machine learning, and designer. I'll explain a little bit more what that is in a little bit as well. I also have access to data and compute, so I can manage, all the different data stores that I need, how to upload my data sets, the compute instances, all of that's tied in this framework. We even have tools for, as I mentioned earlier, pipelining, and I can create pipelines, and I'll show you just quickly in the documentation if you're looking more, that essentially allow us to build an end-to-end solution from data preparation, training your model, packaging your model, making sure it validates and passes certain interpretability benchmarks, deploying the model, whether that's in the cloud or on the edge, and your ability to monitor the model for changes in data flow and rerun the entire pipeline once you get things orchestrated and start. So that's, again, very high level what Azure Machine Learning is in the Azure Machine Learning workspace. Let's actually dive a little deeper and see how we can actually get started with this from every level of your machine learning or data science and AI journey. So at the starting point, let's talk about the Azure Machine Learning beginner level and how you can get started without even needing to write a single line of AI code. And what we provide here is what used to be called the Azure ML Learning Studio. Now it's called the Azure Machine Learning Designer, and it's part of the studio. And what you can do here is we have a bunch of different tutorials, like for example, for regression that I can open up. And what this will do is it will show me when it loads an end-to-end scenario that I can, from getting my data, normalizing, cleaning my data, choosing on a simple linear regression model, scoring the model, evaluating the model. I can choose what kind of compute target that I want to run this on, whether it's a cluster or a given machine. When I click deploy, it will train this model, and then with one click, I can publish the model as a web endpoint. In addition here, we can also do that for our own models. So I'm going to, again, stay at a very high level to explain this. But what I can do is I can either enter some data manually, I can import data from many different web services or data stores, and we'll see in the SDK additionally how we can deal with processing the data. We can pull in data from things like Azure SQL, from external web URLs or web endpoints. We can bring it in from also the Spark ecosystem as well. We have the ability to do data transformations. Again, we can do things like combine different data sources, modify them, normalize. If we have missing values, we can clean those up as well. We can also export the data as a data set that can be used by other features in the machine learning workspace. And then we can also do additional cool things like feature selection. We have a bunch of out-of-the-box traditional machine learning algorithms, from random forests, logistic regression, to SVMs, to, again, a lot of the traditional machine learning workflows. In addition to that, we also have the ability, we also have some more custom things for dealing with different spaces like NLP, natural language processing, so being able to do feature extraction. If you want to do topic modeling, being able to do LDA just by dragging and dropping a a model and linking it to your data. And just linking it to your data. Additionally, we have things for a bunch of the different scenarios we talked about. So for instance, doing image transformations, being able to do image classification or image preprocessing and converting your images into vectors so that you can link them and connect them with other traditional algorithms. And we also have recommendation systems in here, systems for anomaly detection using PCA, as well as other anomaly detection models as well, like single SVMs. And we have the ability, again, to very, very quickly iterate this, control our compute, and without really having to understand how all the code works behind the scenes, we can build and quickly iterate baseline models that we can then publish as web points and consume in our own applications. So that's the first step. Let's come back to our presentation, and let's go one step deeper. So while this is really valuable for people who are getting started in their data science or machine learning journey, or maybe aren't ready yet to just pull in a data scientist or engineer, want to understand what they can do with their data, this is a really good platform for that experimentation. So I can pull in my data, play around, and see if I can get an interesting baseline. The next step would be AutoML. So what AutoML provides is, if you understand a little bit more about the underlying models and options, you can pull in your data set. And what it will do is, based on an analysis of the type of task you have, you define what the task is, whether that's classification, regression, or any other kinds of tasks. You provide your constraints, like what kind of models you want to try out, whether, for instance, if you wanted to try a list of models like random forest, SVMs, you provide the metrics that you want to optimize, whether that's recall, precision, your F1 score. And then what the service will do is it will run many different jobs that are optimized and distributed. And what it will do is, if it sees that a certain job isn't converging or providing better results, it will kill that job and redistribute the compute in a way to help run more and more optimal experiments. And from that, it will return the best performing model for you that you can then play around with as a baseline and put that into production. So we'll take a look at this automated ML. Essentially, the way that it works here, and when we go into our studio, we have this automated ML tab. We have a bunch of different concepts here, so we can look directly in the documentation about what automated AutoML is. So it explains, again, a lot of the different things that we talked about, scenarios like classification, regression, time series forecasting, and essentially, exactly as we discussed before, you upload your data, you define your task, you define what we want to optimize and which models we want to test out. And essentially from there, AutoML will distribute and try to find the best performing model for us. What's really, really powerful also about this is it has some really nice featureization support. So for instance, if I put in textual data, I can choose to whether I want to use my features as TF-IDF, or I can even do BERT-based embeddings for getting better classification results with text. I don't have to actually manually featureize my data. Additionally, we have also other feature extractors for images or time series analysis as well. And we can try many different variations of different feature extractors to try to get the best results. So I'll show you kind of baseline how that works, and then I'll show you a job that I ran. The way that this works is I click New AutoML Run. I choose a data set. So here I have this data set of clothing reviews. We go to Next, and it's going to just take a few seconds just to load my data. The next thing that I do is I provide an experiment name, so I'll call it review sentiment. And then I choose the target column. So here we have text and ratings. And actually, I can view this data set. So let's take a quick look at the data and what we're doing here. So I have a bunch of reviews here, and we have ratings, whether 1-star, 5-star, 2-star, 3-star review. And we want to choose a model. We want to train a model that if I give it new text, will give me a prediction of what the rating will be, so that I can build my own custom, for instance, review model. I can look at the data distribution, so I can see that this data is a little unbalanced, and I can also work on the skew and work on balancing the data myself. And then what I can do here is I choose the rating, I choose the compute target that I want. And then what we can do is we go to task type and settings, and then we can actually start configuring things. So we can say, what's the metric that I want to optimize? So maybe something like AUC. I can set constraints from a compute perspective of how long I want to run the training job, or if I want to get above a certain score on my metric. So for instance, let's say I do accuracy or precision. If I want to get above a 0.7 threshold and I'm happy with that, I can set 0.7 threshold and it will stop training when I have a model that fits my threshold. We can change we have a bunch of different features for cross-validation to make sure that our model is converging and working. We can also define on our compute, if we have a cluster, how many iterations or how many versions of the model we want to train at a given time. So we can also here, if we have text data like I do, we can enable a BERT. And we also have the ability to do auto detection of feature type, or I can manually define it, and we can go from there. So then once we do that, we just click finish and it will run our job. I'm not going to run that now, but I will show you what it looks like. I ran a job earlier. And here, let's see. 1 second. So what you see here is what we can see all the different performance benchmarks of the different models that we run. We can look at the different jobs that we ran. We can see, the top performing. We can dig into this run. So I can see the different models that were created, and I can see the best performing models and how that affected. For example, in this case, we set accuracy as our threshold. I can run into see additional information about the run configurations. We also have the ability to integrate. It's not set up here, but we have the ability to integrate into model explainability if you're using certain model configurations that allow you to better understand what the decisions your model is making. We can look at different metrics and chart those metrics across different models. And then what's really, really nice is when we have a model that we're interested in that performs pretty well, we just, with one button, we can click deploy. We choose whether we want to deploy that for like debugging, we would do ACI. If we want to do this for production, we would choose AKS, which provides the Azure Kubernetes service. We can even set up authentication so that only authenticated users using AAD or who have specific tokens or keys can run our model. And then we can even include custom entry points and additional modifications to our script. And then we can just, with one click, deploy the model. And we have a production baseline without writing a single line of code. So before I go to the next level of advanced machine learning, I kind of want to quickly recap of everything we talked about here with AutoML. Essentially, what we discussed is we showed how we can very, very quickly go from having a clean data set to uploading that data set, configuring, setting up the constraints, setting up what kind of task we have and what kind of data we have, to getting a baseline. Now, one of the things that I personally feel is that you won't necessarily get the state-of-the-art model with automated ML. However, what it will give you is a solid baseline, and that's very important because before you start going in and writing your own scripts or taking different open source solutions and playing with them from developed in PyTorch or Keras or TensorFlow, I think it's really important to understand your data and the baseline that your data can give with an AutoML model. Additionally, what I would say is when you're investing in AI or machine learning solutions, having a baseline model that you can put in an experimental trial can give you a sense of how much value your machine learning solution actually provides your business or your use case. Often I see this mistake happen a lot in the industry where people go and run and try to take state-of-the-art models and put them into production without understanding all the constraints. And sometimes there can be a really, really big engineering effort, and you can find that the improvement from that huge engineering effort isn't that much more than what you would get from this baseline. Or even worse, you could have a model, well, not necessarily worse, but something that also bad can occur. You can have a model that works really, really well, but a business use case that doesn't really provide much value. And now you've invested a lot of energy and time in this use case and business case, and you have a great model, but it doesn't really do anything for you. So being able to have a strong baseline that we can iterate and deploy and then build on top of is a very, very powerful tool. And then we can go into our next step is how do we actually go and integrate with any machine learning platform? How do we take care of distributed training? How do we put the state-of-the-art open source model into production? And that's what we're going to do here. To do that, we use the last part of the AzureML service, and this is the AzureML Python SDK. And what this does is essentially it wraps all the services from data preparation, model training, experiment management, distributed compute, and the ability to deploy models all into a unified SDK. And again, it runs around everything that we discussed in our workspace, the models, experiments, pipelines, compute targets, everything you know and love in Azure, all ties in here. And to discuss this, I think it's important to take a step back and look at how at Microsoft and with Azure, we view the typical end-to-end machine learning process. In the beginning, you have your data preparation, and typically that happens outside of Azure Machine Learning. That's where you run your Spark cluster or to do analysis and pre-process your data, or it's where you're pulling in a bunch of information from an event hub or a Kafka service. It's where you've aggregated a lot of information across all your different SQL databases or Mongo databases or Cosmos DB. After you've gotten your data set, then comes the experimentation. And this is where you go and you pull in your favorite model. You can run everything either in Jupyter or Visual Studio Code, PyCharm, whatever IDE, Visual Studio, whatever IDE you want. You pull that in, you iterate your model, and then you have the ability to actually train at scale, iterate and manage this. And then when you can register that model, and we can do very, very simple deployment with the SDK. So what we're going to be focusing on here is this experimental phase of how do we train and iterate and register a model using the advanced features of the Azure Machine Learning SDK. And I'll show you a real-world example of a model that would be a little challenging to build with AutoML or the designer. So when we think of ML, production machine learning, there are a couple of major challenges we have when we work beyond academia in a standard data science team. One of the first challenges we have is managing all our environmental dependencies. When I'm working in a research setting, so one of the things I do is I work in a ML, natural language processing research lab. And one of the challenges there is often we work on our own machines. When we transfer code, we email it, maybe we put it on Git. But one of the biggest challenges is when you're actually working across a large distributed team, you need to make sure what works on my machine will work on everyone's machine. So we need to be able to handle environmental dependencies. We need to be able to also go one step further in terms of managing cross-team collaboration, and how do we deal with working across teams distributed all over the world, or in a given that aren't, especially now that we're in a more remote working world, how do we work in a more distributed manner? We need to deal with data and compute management. We need to make sure that we're properly managing our data and compute costs, that if I need more compute, I don't lose my entire job and it doesn't just crash, that it will naturally scale, but also that I can set constraints for that. I want to be able to control data management, so I want to make sure that only the right people on my data science team have access to the right data sets. And I want to be able to handle compliance and interpretability. So one of the really important things that we actually provide with Azure Machine Learning Service is the interpretability and fairness toolkits that can help with interpretability. I think there was another presentation on that, but I'll provide resources as well. And then in terms of compliance, well, you still have to manage some of the compliance yourself. One of the advantages of using Azure or cloud-based systems is that all the building components from data to compute go through a very, very stringent compliance process. And we work with a lot of the different compliance ISOs and certifications from HIPAA and like. So one of the things that helps with, well, again, you still have to make sure that you're being compliant as an end user. What it does help with is if you're managing the whole end-to-end process yourself in terms of compliance, it can get overwhelming. So it helps manage some of that. And then the last really important thing is distributed training. So instead of getting into the challenges at a very minute level of everything, we can just, let's take a look at distributed training and see all the challenges that somebody might have to deal with when you're trying to scale a production machine learning model. So first, as we talked about, you have to deal with making sure your dependencies scale across all your nodes and devices. You need to be able to schedule jobs, cancel jobs, scale jobs. You need to be able to make sure that your data distributes correctly to each, and that each of your nodes has access to the right amount of data, that they don't lose access to the data, that there's not overlaps. You need to be able to scale up and scale down resources. You need to be able to provision clusters of VMs and other instances. You need to be able to aggregate your results from across all your distributed training and compute. And you need to make sure that you secure access. You want to make sure that nobody's manipulating your service, or that none of your nodes are compromised, and that nobody's using that to affect your production model. And you need to also be able to handle failures and rollbacks. So even for the most professional of engineer, these challenges can often be overwhelming, and being able to provide a scaffolding through the AzureML SDK provides us more time to actually focus on the machine learning and engineering tasks that we want to solve. So what's really nice is that the AzureML service provides, through OpenMPI, direct integration into Horovod for distributed training, as well as a lot of the different batch mechanisms in PyTorch and TensorFlow and Keras as well. So now that we've talked about some of the benefits and why it's worthwhile to use a framework like, or an SDK like Azure Machine Learning for training your models, as opposed to just doing everything on your own, let's actually talk about how it works. So the way it works is that you have your own computer that you're developing on. You can even run locally on this computer. And what you do is you build your baseline model. Once you have that baseline model, you send it as a snapshot, as a new experiment, or an addition to an experiment on Azure Machine Learning. Additionally, what we do is we provide configuration information for our compute environment. And what this will do is it will bundle everything up into a Docker image, which will be linked to our compute target, which typically is a cluster that scales. Additionally, we externally upload all our data to our data store, which gets mounted to the compute target. Our entry script for actually training our model gets run. And then as if we're running on our own machine. In fact, you can run this process through the SDK on your own machine. All the streams, all the outputs, and all the logs come back to me in real time. So there's 8 steps that you need to be aware of to make this work. And I'm going to show you a demo in just a second of how this all comes together. I promise you it's more simple than it looks from this overwhelming 8 steps, but it's pretty simple. The first is we need to configure a workspace, which you saw we already did. We need to define a compute target, which we'll show how to do with just a few lines of code. We need to upload our data set and make sure our data set is in the data store, which again, we can do with just about 1 line of code. We need to create our experiment. We need to provide our training script and the model, open source model that we want to run and train. We need to create a run estimator and then run and submit the job. And when it's done, we need to register our outputs so we can package them up for deployment. So let's actually take a pause here, go back to our workspace, and let's actually look at a real world demo. So one of the things that I've done, one of the challenges that I've often seen as a developer advocate in this space is often when we talk about these amazing or end-to-end pipeline systems that are very, very powerful, like Azure Machine Learning, when it comes to the demo time, often the demos are very basic, and it's like it's like bringing a bazooka to a water fight. A water gun fight. You don't want to do that. It's overkill. What we really want to see is we want to see a more custom scenario or a more challenging scenario, something that would be hard to do out of the box with something like AutoML. And we want to show how we can do that with Azure Machine Learning. So what I'm going to show today is how we can build what's called an audience estimation model with computer vision, doing crowd counting. With Azure Machine Learning. So this started before COVID. As a developer advocate, about a year ago, we would travel to a lot of different and give talks in a lot of different places. And I always was curious how many people I was talking to, right? And what I wanted to do was to be able to, given a picture, be able to have a sense or an estimation of how many people, as an advocate, the impact that I have, so that I can increase and improve the work that I do. So there's a couple different techniques or methods for audience estimation. One of the techniques, they fall in 2 major categories, detection and dense-based estimation. So detection, essentially, it works very good for small groups. And essentially, there are a couple different ways that we could do that. We could use object detection, pose estimation, or object segmentation, instance segmentation, to try to understand how many people there are in a crowd, and then we can try to use that to count. Now that works when you have like 20 people, 5 people, 6 people, but when we have a larger crowd, like the one in this big auditorium here, these methods have, it's challenging to get these methods to scale. So what we're going to look at is building a model called a multi-column MCNM. We're going to use an open source framework called the C3 framework, and we're going to use the AzureML SDK to quickly go from open source, just a model that's on this GitHub repo, and actually train it in a scalable way using the Azure Machine Learning service. Now, everything that I've done here, and I'm going to go here, and I'm going to put this in the StreamYard link for you guys. Everything that you're going to see today is something that you can do at home as well. Let's get started. So the first thing that I need to do is I need to go back to my workspace here. And what we're going to want to do is we're going to want to create an instance that I can develop on. So the way we do this is we create what are called compute instances. And what's really powerful about a compute instance, now keep in mind, I don't have to use a compute instance. I could open up Visual Studio Code, and I could work from my own device or whatever idea I want. But what's powerful about a compute instance is that the AzureML service manages all my files and experiments. So I can create different types of machines that leverage GPUs when I need to actually run a GPU job and test a baseline model before I scale it out with a full service. But also I can run very low powered and pretty cheap CPU machines that I can later spin down and spin up a GPU one when it's time for dealing with larger compute. So in the same way that we can scale training with the Azure Machine Learning Service, I can also scale my compute resources as I'm building the scaffolding that I need to run a machine learning job. And what's really powerful about these tools is these instances come with Jupyter, they come with Python, they come with RStudio, they come with PyTorch and Keras and TensorFlow and Pandas and pretty much every single one of the key dependencies that I want already pre-installed. So it's very easy to get started from here. So if you're interested in learning more about what the compute options are, there's more information on each one. What I have here is a standard N-series compute instance, which I will walk you through how to get started. So now that I have my own compute instance running, I just tap Jupyter. What this is going to do is this is going to open up my Azure Machine Learning Jupyter workspace. And I can just go into crowd counting here. And I can go into AML crowd counting. And I just click AML crowd counting notebook. Now you're probably wondering, where did that come from? Well, what's really cool here is because it's Jupyter, I can just open up a terminal. And I can do AzureML audience estimation. And in the post that I sent you, all my code here is open source. And because Git is pre-configured, I can just take this repo, and in the terminal here, when it loads, I can just clone this here, and now I have all my repo and all my information here that can run across any of the compute VMs that I create. So that's how I got that data. So the next thing that I do is I open my Jupyter Notebook, which you should all be familiar with by now. What we're going to do is we're going to set up we're going to do the first 3 steps. We're going to set up our environment. We're going to link our workspace. We're going to create a compute cluster, and we're going to set up our storage and upload our data set. So here what we do is we clone the framework. I can also, in addition to doing it in the terminal, I can do it here as well. We're going to clone the C3 framework. The next step that we're going to do is we're going to import AzureML. We're going to connect to the workspace, and we'll create our dataset directory. Then the next thing we're going to do is we just upload our dataset, and we can do that with 1 line of code. And because we're using Azure Blob Storage, it's very cheap, and also we can upload very big datasets. So it's ds.upload. We give our dataset a name. We provide a target from where we're uploading it, and we can just show progress to show things. And we can set overwrite to true or false if we want to overwrite an existing dataset on our data store. Then the next thing we need to do is set up our compute. Very, very simple here. It's just about 4 lines of code. We import compute target and AML compute. Also, you can import the compute target exception. I'm going to make the text a little bit bigger so it's easier for you guys to see. And then what we do here is with the compute config, we do aml.compute, provision and configuration. We choose the size of the machine that we want for our cluster, the minimum amount of nodes we want to run, the amount of nodes that we want to scale to, And as a pro tip, you can set to low priority nodes, low priority instances. And I'll put in here in the documentation, AzureML low priority instances. These are compute instances that allow for really a lot of cost savings. And the advantage for using Azure low priority instances when you're doing batch jobs is essentially what happens is you get a cheaper rate, and if you need to be evicted from a VM, the Azure Machine Learning Service knows how to not kill the job, but to manage being evicted and pulling in another instance. So okay, let's go back to our notebook here. So we now have a compute target. Now we want to actually take this open source model and train it. So the first thing that we need is a train script. This is the transcript that I've written for using creating an AzureML trainer for the task of audience estimation. For the sake of time, I'm not going to dive into everything here, but you can see it's your standard code. What's important here is that we provide a couple different inputs, like the max number of epochs and our data folder, which later we'll link when we submit this experiment to our data set that we've uploaded to our data store. Additionally, you can put in any other hyperparameters that you want to tune here, and later I'll show how you can use hyperparameter tuning to optimize your models. After that, we write this out, and then we can create our experiment. So what we do is we give our experiment a name, we assign it to our workspace. Then what we have to do is we create a run estimator. So we provide any parameters that our script takes, in this case, our data set. We provide the source directory of where the train script that we wrote out to is, our parameters, the compute target. In this case, we're using GPU, so we need to provide use GPU equals true, the name of the script that we want to run, and any dependencies that we're using. So you can see here we're using PyTorch, the Torch Vision. We also have the ability to use TensorBoard, TensorFlow, Pandas, and a couple other things as well. And then what we can do is we just submit the job. And so what I'm going to do here, one second. What I'm going to do here is I am going to show you what happens when we run the job. So this job took about 2 hours to run. So I'm not going to run it from scratch now, but what I will show you is what happens is we can see the driver logs, and everything that we log out here, we can actually see and analyze in our driver log. We can also, in the Azure Machine Learning Studio, and this is what's really cool, we can also monitor and compare different runs and different versions of our experiments. So I'll give this a second to load. And here you can actually see the performance across this run or different runs of the job. We can link it to our explainability APIs, and we also have snapshots, so we can actually go in and see different versions of the code and compare them when we have multiple versions of a given experiment. So that was run 19. I can also look at performance across many of my different runs and see how different changes to my training script affect my code, and then I can zoom in and see actually the differences in the code. So if I'm working as a distributed team, we can quickly converge on a state-of-the-art model. So let's go back here. Once we're done, we just need to register the model for evaluation. So we do run.register model. We give our model a name. We put the path, the output path from our train script. We can define whatever framework and metadata we want here. And we also define a resource configuration of what we need to actually evaluate this model. And then what we can do is we can either run this model on the edge locally on this machine, just by doing model.download here. And I'll show you kind of, we load up this model. I have this image here, and we can run the model, and you'll see that you'll get this output estimate of how many people are in the image. And we can even see what the projected mask of the image was. And from there, we can do additional really cool things in terms of production and hyper-optimization. And I'm going to go into that really, really quick, and then we'll sum up here. So what is hyper-optimization? So as we talked about, different scripts have different models have different hard-coded input values, like our learning rate, the number of layers that we put in. And often, we want to be able to know, if we change these values, what impact that will have on the model. Now, traditionally, in like a standard setup, the way that we do this is we come up with our algorithm. We choose a set of hyperparameter values. We get a model, and then we change the values, get a second model to see if it's better than the first. And we do that many, many different times. And each time we run the whole model, get the result, change it. And you can imagine that after a while, we get to the point, but if something changes in the algorithm, we have to do that whole process all over again. And it becomes really, really complex, tedious, repetitive, time-consuming, and expensive. So what automated hyperparameter tuning does is it allows us to do a couple of different things. It allows us to provide a range of values to explore. It allows us then to run multiple versions of our job. And then we can also set up different early termination policies that enable us to terminate jobs that are not with hyperparameters that are not outperforming previous jobs. And in doing so, we can then reinvest that compute into either training more jobs or reducing the overall cost. And that ends up being a big cost savings. So just for the sake of time, if you're interested, I'll upload the slides, and there's all the documentation there. And with that, let's wrap everything up and take questions and answers. A lot of documentation here, a lot of best practice guides for natural language processing, computer vision recommendation service. Also, I invite you to take a look at Microsoft Learn, which gives a whole large overview of a lot of the different concepts that I discussed today. And with that, I'm going to come back to the call here, and I'll open the floor to questions.
So thanks a lot, Ari. So we have, yeah, I'll just pin the question. Can you say it?
Let's see. Let me see the live comments. I think maybe one of the things that would be really helpful, can you moderate and take a couple of the questions, and then I'll answer them as we go along?
Sure. So Preeti Sharma is asking, have done this on Azure Machine Learning Studio, but can we perform accurate? If then, how?
All right. Can we perform accuracy? So I guess, is this for, I need a little bit more context. If we're talking about for the designer, so in the designer that we discussed earlier, there's a whole list of different benchmarks, such as accuracy, precision, recall, F1. Everything that you do there, you can, pretty much any of the standard benchmarks, you can optimize for. Also for AutoML, you can do that as well. What's really powerful about actually the AzureML SDK is that you can define custom benchmarks. So for instance, if I'm creating a summarization model and I want to use as a benchmark like Blue, which isn't typically supported by scikit-learn or traditional metrics library, I can define that, and I can do my hyper-optimization to optimize that custom benchmark. Yeah, let's take another question.
Yeah, so we have one question. How do we pipeline multiple algorithms in AutoML?
All right, so there are two separate things. So one is AutoML automatically does that for you. So what it will do is you provide what you can set up automatically. It will search the whole algorithm space for your given for your given configurations. you can actually filter. So you can actually, if you, let's say, don't want to train a naive Bayes model, you can remove that from the search space. And you essentially, you set the constraints. You set how much time you want to provide, how many models you want to try to train at once, what the input parameters for the models will be. And what it will do is it will pipeline and try out multiple different algorithms based on the data that you've uploaded to try to kind of find the best model. And if you wanted to try more models, you just give it more time.
So I guess your question is answered, Naveen. So Anurag Singh has one question. I see this is in preview version. Is it advisable to use it in production?
So there are different services in AzureML. I agree that some of the stuff is preview. I do think that again, so I would take that with a grain of salt. I do think that certain aspects of the service are good to be used or to play around with, and they provide a really strong scaffolding. Again, my personal advice is you need to test out whether it works for you and take that risk threshold for yourself. I wouldn't necessarily say take a preview service and run to production with it, but I do think that there are features here that are very valuable.
All right. So Santosh Kumar asks, is DP100 an expert level certification?
Sorry, can you repeat the question? DP100 expert level. So I'm actually less familiar with all the different certifications. Yeah. I mean, this might be a better question for some, because I know that there's been a lot of changes in certifications over the past couple of years. I'm going to pass on that question, but if you have other questions around the actual service or the tooling, I'm happy to answer those.
All right. And then there is one more question. I mean, it's pretty big. I'll just display it over a screen. Can you see it, Ari? Can Azure ML handle IoT data directly from Cosmos DB or any other big data platform to build an ensemble model?
Yes. So actually, that's one of the really powerful things here is because everything's built on the same infrastructure of Azure, you can set your Cosmos, you can pull your data from Cosmos DB or from other Azure services like the Spark ecosystem, or you can even set up a pipeline to pull in and process data as it comes in through your like Event Hub or your IoT Hub. And then you can use that to trigger a pipeline that you can either set up your own custom ensemble modeling, or with AutoML, one of the options that you have there is that it sets ensemble models up for you.
All right. So following up, Naveen is following up with his previous question. How do we pipeline multiple algo in AutoML? So he has one more question. If I need to create a web app to create a web interface, how do we go about this?
Sure, absolutely. So I'll share my screen again so that you can see it. Yeah. This was one of the things that I was talking about a little bit in the service earlier, is if we go to AutoML, we go to one of our runs, and I take one of our models. So this will also help answer some of the other questions here. So you can see that there are a lot of different models and configurations, and some of these actually are ensemble models. And I can take one of these models, and I click deploy. What you'll see here is you have some advanced features in the deployment. And one of them is use custom deployment assets. You can use this to actually even provide an endpoint for a web service. And there's actually, if you look at what I would suggest looking at also in SDK is if you look at the work that we did from the past Ignite, is actually an example of this here, where the service that actually gets set up is a front-end website that you can interact with, a demo of the tool. So I hope that answers the question. The
Yeah,
answer is yes.
yeah. We have one more question. So, is there a way to determine feature importance in an ML model, in a predictive ML model?
Yeah, so, well, okay, it depends a lot. So this goes into model interpretability, and it depends a lot on what kind of machine learning model or approach that you took. One of the most common ways to look at feature importance is to use what are called SHAP values. And we actually provide a framework for actually calculating SHAP values for your model. If you're interested, I actually have a blog post, if you check it out here, called How Coalitions Can Help Detect Bias in AI, that kind of uses this concept of SHAP values, and the Shapley formula walks through essentially the history and how it was developed, and also how you can integrate it to get a better sense of feature importance for your own, and use the Azure Machine Learning interpretability to get started. So what I'll do here is actually, we'll go here, and I'll send this in the chat to everyone. I think this should, I don't know if this just sends to you or if it sends to
I,
everyone.
I'll forward this. Not an issue.
All right, so I'll do that, and I'll also, I will send the Ignite example here as well, so that people can look at these code examples and dive a little deeper. Additionally, tomorrow I will upload all these slides to SlideShare, and I will tweet them at the group. So keep an eye out. I'll even use the hashtag AzurePiDay to make sure, keep an eye on that, and you'll get all this information there. Awesome. How are we on time? I know that I used up a good amount of time here.
No, not an issue, not an issue. I mean, like, it's like just 2 more minutes. Just 2 minutes more. Not an issue. We just have well. Thanks a lot, Ari, for that amazing presentation and for that informative session. So I'm very sure our viewers out there have found it really amazing. So we have one of our teams of from Mishmash will be presenting like what they've built during their hackathon. So I'll just add him to the stream.
So I'll turn my camera off, and I'll go on mute so that they can.
Yeah, and also Ari has some laptop issue. He had some battery issue. So I mean, you can turn off.
My computer did not catch fire, so we're in good hands there.
All right. Okay. Then I'll just actually. So hi Pushkar, can you just start sharing your screen?
Yes, give me a second.
Yeah. So guys, we have Pushkar from Team CMites. They were one of the top teams of Mishmash. So he would be demonstrating on what they've built in their project and how did they build it.
Shubham, is my screen on?
Yeah. Just a second, I'll add this to stream. All right, Pushkar. I mean, it's
I have shared.
there is some issue. I guess
Yeah,
it's
I
all.
guess my screen. There's some issue with my internet as well, actually. Let me know when you can see
We can see your screen, Pushkar. I
my
mean, you're good to go.
screen.
Yeah.
I guess you can see my screen,
Yeah.
right?
Yeah, Pushkar. Yeah. All right.
Okay. Okay. So the yeah, I'll just start. So the problem statement given
Pushkar, could you just check with the internet connection? Like your voice is not audible. Or okay, I guess we have some network issues.
Hi, Pushkar, can you hear me?
So Azure, Pushkar has some issues at his end.
Yeah.
Yeah.
So
So
I
well,
Shubham, he has some issues. Maybe we can, since we are running late on time, I
yeah,
guess we can go ahead and.
exactly. Yeah. So well, thanks a lot for joining, and thanks a lot, Ari, for joining. So it was a pleasure having you. And also, guys, we have one more meetup coming up on 20th. So you can just go and register on that. It would be a basic session of AI in Azure that is under the series of Azure, Build with Python on Azure. So yeah, thanks a lot. Bye.